Sir. Good afternoon, everyone. This is Sujan Rokaya from Mendelif Group. Today I am here to do a presentation. Without doing delay, I would like to start my topic. My topic is electricity and magnetism. It is prepared by Mendelif Group and presented to Ishwar Neopane sir. Magnetic field around a solenoid. The magnetic field inside a solenoid is proportional to both the applied current and the number of turns per unit length. There is no dependence on the diameter of the solenoid, and the field strength doesn't depend on the position inside the solenoid. Example: the field inside is constant. As you as in the figure, it is shown about solenoid magnetic field. Another one is Maxwell's right hand grip rule. The rule states that if a straight conductor carrying current is held in the right hand such that the thumb is pointed in the direction of the current, then the direction in which your fingers encircle the wire gives the direction of the magnetic lines of force around the wire. Magnetic flux and its variation. As the surface moves or rotates between two poles of a magnet, the magnetic flux changes. Uh, Faraday's law states that the change in magnetic flux creates an induced electric current that has an electromotive force or EMF. Mathematically, Faraday's law of formula is EMF equal to minus triangle minus triangle magnetic flux triangle T. Electromagnetic induction or induction is a process in which a conductor is put in a particular position and magnetic field keeps bearing or magnetic field is stationary and a conductor is moving. Faraday's law of electromagnetic induction. Faraday's law states that electromagnetic induction states that a change magnetic field induces an electric current in a conductor. Discovered by Michael Faraday, this principle highlights the dynamic relationship between magnetism and electricity. When the magnetic field around the conductor changes, it produces an electromotive force (EMF) that drives an electric current. This phenomenon is fundamental to the operation of generation, transformers, and various electrical devices, playing a crucial role in the generation and transmission of electric power. As it is shown in the figure how the Faraday's law work or done. Thank you. Okay.
Oh, very good. Okay. So our chapter is electricity and magnetism. In this period, we are discussing the slide prepared by Bian and presented by Sujan. And both of them represent the same group, Mendeleev, D.I. Mendeleev, right? So he gave Mendelev's periodic law that we will discuss in classification of elements. It will come. after some chapters. Understood or not? We are in now 11th chapter, right? It may be in 13th chapter. So yeah, thank you is also here. People are also happy, just going like that. Huh? Very good. So here, what is discussed? Actually, we are discussing now magnetism. What are we discussing? Magnetism. It is the Mahaguru of them, D.I. Mendeleev, Russian chemist. Right? Russian chemist. A magnetic field around a solenoid. First of all, we have to know what is solenoid. What is a solenoid? Do you know? When, okay, this is a straight wire. This is straight wire. When the wire is coiled, and this coiled wire is called, what do you call it? Solenoid, right? So inside the solenoid, especially, they keep one magnetic material. What do they put here? Magnetic material, and it is connected with plus minus, right? When electricity is supplied through this solenoid, then the solenoid also acts as a magnet, because when current is flowing through a conductor, then it acts as a magnet. It also acts as a magnet. When this coil acts as a magnet, if the magnetic material is kept inside it, that also acts as a magnet. Okay, and we know charges, they flow from negative terminal to positive or positive negative. If they flow from negative to positive, then this side here is North Pole, here is South Pole. Understood or not? From which it enters North Pole, or the pole of the solenoid which is connected to negative terminal is North Pole, next one is South Pole. And this coiled wire is solenoid. The magnetic material which is kept inside it and which acts as a magnet is called, what is it called? What is the name? Electromagnet. Electromagnet. What do you think? Electromagnet is temporary or permanent? It is temporary. When electricity is supplied, then it acts as a magnet. When electricity is not supplied, it doesn't act as a magnet. Okay, this is the thing. Solenoid is coil wire. So here is solenoid. So this one, can you see here? Coil wire, and current in, current out. From where goes the current goes? That is North Pole. From where it comes out, that is South Pole. Is that clear? Okay. These things you have to keep in mind. Now, next one, let's see here. Maxwell's right hand grip rule. Right hand grip. Last time, right hand thumb was there. Thumb was pointing the direction of current, and other finger showed magnetic field. But here, what did it show? This right hand thumb rule, it shows, okay, this current, from which the current is going, that is North Pole, another is South Pole, isn't it? So, see what here also same thing. Thumb shows the direction of the current. Current goes here, and next side it shows the magnetic field. But remember, from where the current is in passing, from here or from here, it is coming from down. So, in solenoid, this is North Pole, this is South Pole, right? Right hand thumb rule or grip rule. Next one is magnetic flux and its variation. What is the next one? Magnetic flux. Here we have to remember there are different type of magnets: natural magnet, artificial magnet, rod-shaped magnet, U-shaped magnet, horseshoe magnet, electromagnet, etc. One thing remember: if this is, now we have to use. Let me buy one copy, okay? What am I going to buy? Yeah, became back to this one. Buying copy also became god. Just I What a big page is here, right? So to write, we do it. We need copy. So blank document. What happened? It is not recognizing us or not. I think it also needs some sort of maramat. Dhulo pito or maramat, right? Okay. They will remember my new style also, right? Okay, close here. Uh, but one thing we should not do dhulo pito of this one. So, otherwise, after some time, no work at all. Some maramat is okay, but dhulo pito is dangerous. Say Purnima. Sarbat you can take sarbat and chatu. Dhulo pito. Children, look at here. If I draw like this diagram, then what do you say? What is this? North pole, this is south pole. And these, here are some imaginary lines. These lines are called magnetic lines of force. What are they called? Magnetic lines of force. We just show like this, and magnetic lines of force are always go from North Pole to South Pole. See, North Pole to South Pole. Are they going like this or not? Okay. Then, if we keep here one conductor, what is kept here? Conductor. When the conductor is placed here, then does it caught the magnetic lines of force or not?
Yes.
And some of the magnetic lines of force are perpendicular to the magnetic lines of force. Try to understand it. If a conductor is placed in the magnetic field of a magnet, then it causes the magnetic lines of force. Some of the magnetic lines of force are perpendicular to the conductor. Means how much degree angle do they make? 90 degree. That is called magnetic flux. So the total number of magnetic lines of force which are perpendicular to the conductor when it is kept in magnetic field of a magnet, that is called magnetic flux. When it cuts, suppose if you keep a conductor, then there won't be any magnetic flux because it is not cutting the magnetic lines. Is it cutting? Okay, if you take another conductor and place from here, then does it also cut the magnetic lines of force or not? So that's why when a conductor is placed in the magnetic field means the region around the magnet up to which it can attract those magnetic materials. And inside the magnetic field, there are some imaginary lines. Those imaginary lines are called magnetic lines of force. What do you call them? They are always curved. They do not intersect. Start at North Pole and end at South Pole. These things you have to remember. So when a conductor is placed in the magnetic field of a magnet, it cuts the magnetic lines of force. Some magnetic lines of force are perpendicular to the conductor. That is called, what do you call it? Magnetic flux. What is it called? Magnetic flux. One thing, if we keep one time, only magnetic flux is less, right? But when we rotate the magnet or when you rotate the conductor, then flux will be more. Many they will be perpendicular to the conductor. So now let's cut here. What was his presentation? Presentation was here. Magnetic flux. So what is given here? As the surface moves or rotates between two poles of a magnet, the magnetic flux changes. Faraday's law states that the change in magnetic flux creates an induced electric current that has an electromotive force, EMF. Mathematically, Faraday's law formula is EMF equals to delta pi delta T. Okay. So here, Michael Faraday in 1831 AD, in 1819, overstate they found electromagnetism. In 1819 AD, Michael Faraday, he did one experiment. What did he do? One experiment was done. And what are here? What are these? Magnetic lines of force. Here are magnetic lines of force. Then he caught these all. And what was kept here? G. Galvanometer. What does galvanometer do? Measures the current. What does it do? Measures the current. And when it was connected with galvanometer, it shows some sort of charge or current. When there is change in magnetic flux, what is induced? Current is induced. That is Faraday's law. What is that? Faraday's law. What is his law? What is given here? The change in magnetic flux creates an induced electric current that has an electromotive force. Or in our simple language, or what can you say? When the magnetic flux linked with a closed circuit changes. What do you say? When magnetic flux linked with the closed circuit changes, then what is produced? EMF is produced, electromotive force is produced, or a kind of voltage is produced. As a result of voltage, what is produced? Current is produced. So this technology is used in dynamo. This technology is used in generator, etc. In generator, dynamo, what happens? There is change in magnetic flux, and as a result, what is produced? Current is produced. So this technology became a great success in the field of physics. Now see, this fan is operating because of this technology only. Where is the electricity produced? Where there is sufficient water, right? It may be produced in Gulekhani 1 or Morsangdi. Sorry? Inverters matter is different. Inverter, what does it do? It converts a high AC to low AC, and again, that actually it just changes one type of AC to another type of AC and produces that, isn't it? But there is no production. But in hydroelectric power plant, electricity is produced, right? So here is given electromagnetic induction. What is the definition? Is a process in which when a conductor is put in a particular position and magnetic field keeps changing, or magnetic field is stationary and the conductor is moving. So what is actually definition we have to give like that? The phenomenon, actually electromagnetic induction is a phenomenon, process. The process by which current is induced in a conductor when there is change in magnetic field. What I said? Electromagnetic induction is a process or phenomenon in which electricity is produced in a conductor when there is change in magnetic flux or magnetic field. Okay? So who gave that principle for the first time? Michael Faraday. And Michael Faraday, he propounded 3 laws also. How many laws? 3 laws. What are the first? What are they? A changing magnetic field induces an electric current in a conductor. When magnetic field is changed, then what is produced? Electricity is induced. Then again it says, I think all are not given here. I'll just show you from our main course book. In main course book, there must be given 3 different laws. How many laws should be there? 3. Where is our book? Our book Gayab? Yeah. Because this board is not, it's last time, okay. Oh, this is the last page. Last page means what is the page number? Page number 268. Okay, 268. Changes and electromagnetic force or EMF is induced in the coil. This is first one. Second one, the induced EMF lasts as long as the change in the magnetic flux is taking place. There is production of EMF till there is change in magnetic flux. When magnetic flux changes, then EMF is produced, current is produced, otherwise none. Point number 3, the magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux. If more magnetic flux change, more current, less magnetic flux, less current. And induced EMF is directly proportional to, that is same thing. Number 3 and number 4 is same. So these 3 laws you have to remember. What is the first law? Whenever the magnetic flux linked with the closed wave changes, an EMF is induced. Uh, as a result, current is induced. Number 2, the induced EMF lasts as long as the change in the magnetic flux, and the magnitude of the induced EMF is directly proportional to the rate of change of the magnetic flux linked with the closed circuit. Mathematical, this is not the point, okay? That is mathematical. Up to here is done. So, which are the devices based on this one that will be discussed in another period? Is that clear? At first, take out your book and read page number. Which page numbers are there? 200, 266, 67, 68, right? 3 pages are there. Okay. Then you can do your activity. Is that clear? Come on.